Today we are still looking at linear and nonlinear graphs and how to interpret them. Your essential question is, what is the difference between a linear and nonlinear graph? Your learning intention. I'm learning the difference between linear and nonlinear graphs and how to interpret graphs. So for your warm-up, first you need to graph the table. Then you need to figure out the slope and what it represents, and then the cost. So, to raise money to buy a microscope, 4 friends decide to start a dog walking business. The table is what they've done, so graph the following table. What is the slope and what does it represent? If the cost of the microscope is $254, how many dogs must they walk to have the money for the microscope? So go ahead, pause the video and graph, and then we will see if your graph looks like mine. Well, I hope you tried to graph. Now, what I notice is I start at 8 dogs and $19. So this is my dogs walked. And then my profit in dollars. I need to move that a little bit further away because it will get in the way of my numbers. Okay, now, what I notice is I don't have anything till 19. So to show that I've kind of squished the graph down, I use this line till I get here. Then this will be 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now, same thing happens this way. I'm going to squish it this way, bring it this way. I'll have 8, 9, 10, 11, and 12. This last one here will be 12. So, when it's 8 dogs, it's $19. So here's 8, and I come up to 19. When it's 9 dogs, I end up with $22. $10 dogs is $25. 11 dogs is $28. Could they start with a negative balance? Actually, yes, because they might have to buy a leash, they might have to buy a harness, they might have to buy those things to help them get into the business. But if we're looking at it, what is the slope and what does it represent? We can use either the graph or the table. If I'm looking at the table, it goes up by 1, this goes up by 3. So my slope which is delta y over delta x, is equal to 3 over 1, or simply 3. So the slope is 3, but what does it represent? For each dog, the cost goes up by how much? $3. So it costs $3 to walk a dog. Okay, now remember, they're trying to get that microscope. They want to buy that microscope, and there's 4 of them. But the cost of the microscope is $254. How many dogs must they walk to have enough money for the microscope? The equation for this graph is y equals 3x minus 5. So now what? Well, we know the cost is equal to 3 times some number minus 5. So the cost is 254. That's the amount of money they need, is equal to 3 times x minus 5. Let's solve. We start by adding 5 to both sides. $259 is equal to 3x. Divide both sides by 3. $259 divided by 3 gives me 86 1/3. Can I walk a third of a dog? No. So they have to walk 87 dogs to get the money. That's a lot of dogs to walk. 87 divided by 4, well, if it was 88, it would be 22 apiece. So if they did 22 dogs apiece, they'd have enough money. Might be a little extra money for tax there. Okay, so we're going to start interpreting what graphs mean. The graph here represents the speed of a swimmer during a race. Describe the swimmer's speed during the course of the race. Okay, stop and think. This is your time and this is your speed. What happens at the beginning? They took off really fast. They jumped into the water. Actually, they dive into the water, so let's put dive there. So here they're diving into the water, and what happens here? The dive takes them at a rapid speed. Okay, so now they're here. Now what happens? They maintain a rapid speed for a while, and then they get tired. They start slowing down because they get tired, because here they are going less, not as fast. Now, that's assuming they're in a swimming pool. What would happen if they were in the ocean? Well, that might be where they hit a current. That might be where they hit the waves. So we could have made any story up that we want as long as we show them starting off at a rapid speed. The speed is still fast, but they level off on the increase, and then they get tired and start decreasing. Okay. Emmanuel walks the North Trail at his local park. The graph shows the distance from the fountain at the center of the park. As he walks along the trail, use the graph to answer the following questions. Okay, number 1, we'll circle the correct answer. Each section of a graph is linear or non-linear. Well, if I'm looking, linear means that straight line, and those are all straight lines. So it is linear. The slope for the first part of the walk is positive or negative? That would be negative. This means that the distance from the water fountain is it increasing or decreasing? This is the distance on the trail. This is the distance from the water fountain. If they were right here, they would be right on the water fountain. Is it increasing or decreasing in that distance? It's decreasing. The slope for the second part of the graph is. Now let's look at it. It's not going up, it's not going down. That means it is 0, which means this distance from the water fountain is not changing. So he might be walking parallel to that water fountain. Now if we're looking at this, I should have color-coded that first part I wrote in green, we'll highlight in green. That is negative. Okay, now the slope for the last part of the graph is positive or negative. It's going up, so it's positive, which means that his distance from the water fountain is increasing or decreasing. Remember, this is where it's right at the water fountain. It is increasing. Okay, this time you're going to write the graph, draw the graph. Selena hikes a trail. Her elevation decreases at a constant rate until she reaches a stream. Her elevation stays the same, walking by the stream, until she climbs a hill at a constant rate to reach the campground. Sketch a graph to represent the situation. Okay, so if she's decreasing, that means what? Where do we start? Well, if she is decreasing, that means we're up here and we're going to go down. We tried to make a really straight line. Then her elevation stays the same, walking by the stream. Now, what happens last? She climbs a hill at a constant rate to reach the campground. So here we go up the hill. Here's the campground. Is that the only way? No. You could make the descent even sharper. You could make the ascent even sharper. It just kind of depends on what you think. So this isn't the only way to draw the graph, but the form of the graph should be fairly consistent. So, how do you know you're successful? You know you're successful when you can draw and interpret graphs. These are linear graphs. We're going to draw and interpret.